Hello, and welcome to Masters with Masters. I'm Ed Hoffman, the NASA Chief Knowledge Officer. We're here at the NASA Glenn Research Center. Today we'll have a discussion with Dr. Ricky Shine. Dr. Shine is the Director of Research and Engineering at the NASA Glenn Research Center. In that role, he's responsible for the leadership of a workforce of over 1,100 in terms of research and development competencies in propulsion, communications, power, materials, and structures for extreme environments. Dr. Shine joined the Glenn Research Center in 1984. He was appointed to the senior executive position in 2005. He's had a long and distinguished career at NASA. He received his bachelor's from Tennessee State University and a master's and a PhD from the University of Toledo. It's a pleasure to have time with you here today. We appreciate that. What we'd like to get started is get a sense of some of the background in terms of your careers, your challenges, some of the lessons, and we'll make that available across NASA. And perhaps the right starting point is, what was it that led you to an interest in science and engineering as you were growing up? Was there a particular aspect that led to curiosity?
Well, thanks, Ed, for having me and for having this opportunity to share some of my experiences. I really sort of got into science and engineering by accident. My first passion was to be a lawyer. And early in life, I guess I watched too many Perry Mason episodes, and I wanted to be a lawyer because my parents would say, you know, you do like to argue a lot sometimes, and you like to challenge the status quo. So I was looking at this law path, and when I got into high school, I actually met a lawyer that I was talking to, and he sort of became really one of my first mentors, and we started a discussion about the law profession and what would it look like in 15, 20 years from now. And he said to me, well, you know, there's going to be a lot of general practice lawyers in 15 to 20 years. There's going to be a glut of those. So you should look at specializing. And I said, well, specializing, what does that look like? And you know, what are those specializations? And so he mentioned tax law, you know, an accountant, a CPA with a law degree. He mentioned patent law, scientist or engineer with a law degree. And I said, I've been taking a lot of science and math courses in high school in the college preparatory curriculum. I said, so maybe I'll do the science and engineering thing. So it really wasn't until late in my sophomore year in high school that I made a decision to go in engineering. I decided to go into mechanical engineering because I had shocked myself enough as a kid where I didn't like electrical. And so that kind of threw electrical engineering out. Civil engineering, when I looked at that, and I said, well, that's kind of interesting. But when I looked at the mechanical engineering, I thought it had some broadness to it, and I thought it was going to give me an opportunity to learn some things that I really wanted to learn as far as heat transfer and fluid mechanics and things like that. Those are always things that I always wondered about when I was growing up in Dayton, Ohio, and actually growing up not too far from Wright-Patterson Air Force Base. I knew that fluid dynamics and things like that had something to do with aircraft, and I was always intrigued by that, so that's how I got my start into engineering.
So there was a curiosity at an early age in terms of planes and engineering and how things worked, and that got you into that kind of a path.
Well, absolutely. I always thought it was very interesting. It would be a clear sunny day in the summer. I would be out playing with my brothers and sister and friends, and I would hear lightning, at least what I thought was lightning. And it was actually what I was hearing was sonic boom of the military aircraft that were taking off, and they were doing training missions from Wright-Patterson Air Force Base. Then I didn't know that, but now I do. So again, that's what sort of stoked that initial curiosity and got me on the path to engineering.
Right. And so what led you into the direction of NASA?
Well, that's another one of these curious stories. And so, you know, again, growing up in Dayton, Ohio, I knew a lot about Wright-Patterson Air Force Base and the Air Force Research Laboratories. I didn't even know there was a NASA Center in Ohio. My junior year at Tennessee State, I was talking with one of my classmates, and he was actually from Birmingham, Alabama. He was an electrical engineering major. And we were talking about, what are you going to do this summer? And he said, well, I'm going to work for NASA. And I said, oh, in Huntsville? And he said, no, in Cleveland. And I said, in Cleveland? So that's how I found out that there was a NASA center in Ohio, was when I was in Nashville, Tennessee, from somebody who was
So you were
from
in
Birmingham,
Tennessee.
Alabama.
Yeah.
That's how I found out that there was a NASA center in Ohio. And so he came back after that summer and he told me he had a really great time there doing his summer internship. And so the next year, I actually applied for a graduate school fellowship. And so as part of that process, my name was actually sent out to a number of different companies. And NASA Lewis at the time was one of the organizations that my name was sent to. So they actually contacted me and said, would you be interested in coming and do a summer internship? And I said, yes. I came up I-71, and the rest of it's pretty much history. I thought it was just amazing being here. And for that summer, got exposed to a lot of different things. When I came in, I was working in compressors, doing compressor aerodynamics. And I got an opportunity to walk through several buildings, and as I was walking through buildings, I was seeing names on the outside of different offices. And a lot of those names were names, I said, well, God, that name looks familiar. And at the time, it didn't register with me. And then I went back to school, and I realized that a number of the textbooks that I was using, those guys' names were the guys' names outside those offices that I was seeing, especially in heat transfer and fluid mechanics. And a lot of people may not know this, but especially back in the early 50s, that Lewis Research Center, or Lewis Aeronautical Propulsion Lab at the time, was regarded as one of the foremost heat transfer research facilities in the world, with the collection of scientists that they had here. And so I was just amazed and astounded by that these individuals, again, that I'm studying their textbooks, that I actually got a chance to see those individuals and meet those individuals.
And when is it that, obviously you had a good experience because you stayed. Was there a certain point in time, or was there?
Well, actually, I went back to school
Okay.
That fall semester, and I didn't know whether or not what I was going to do permanently after that. I was looking at maybe going to graduate school full time, and I ended up getting an offer from Lewis Research Center, and I called them and said, yes, I accept. And of course, you had to send things via snail mail back then. And then I started then in February, full-time in February of 1984.
And what impressed you in those early years, because I assume that would impact how you lead now, the workforce? Were there certain things that made you say this is a place that you can make your career, this is where you make a difference? Was there things that impressed you?
I think that there was a combination of things. Firstly, when I came in, I had done a lot of computational modeling. So when I first started, I was doing a lot of computational modeling. Again, compressor aerodynamics. Then maybe about 6 months, 7 months into my tenure here, I got an opportunity. One of the senior engineers came into my office and said, hey, come with me, I want to go show you something. And I was like, okay. So we went over to one of the compressor test cells, and he said, I want to show you, some of the experimental work that we do. And I was like, okay. And I really, that was really my first time sort of being immersed in an experimental test environment. And I got there, and I liked it because it was something that was a little bit different than just doing a computer simulation. You were actually getting real data with real hardware. and you can just see, test results, go in and make hardware configuration changes, and then test it, and then compare that against the actual computer simulations. And I found that to be really, really intriguing. And so that sort of embarked me on this, this career, as I called it, where I sort of lived in these two different worlds, where I still was doing computer simulations, but I was also doing experimental work. And it really taught me the value of both. And it also gave me, I think, the challenge that I was looking for, where I wasn't necessarily doing the same thing every day. Doing computer simulations is great. Back then, that's when we were still using the card decks.
Cards, yeah, that if you dropped you, yeah.
Yeah, so if you dropped them, or if you had that in column 6 and not in column 7, right. Okay, you wonder why your job didn't run, or here we had to put everything in, and then it would run overnight, and you would come back and you would find out that you had that one error, and you had to go in and you had to correct that. Yeah. Experimentally, you would be sitting there and you would be looking at data, and you would get an opportunity in a more real-time manner to be able to see if something's, if there's a static tap that's reading incorrect pressure, and there's other static taps in the same vicinity, you would know if there was a problem, versus having to wait overnight many times to go do that. So I found that to be intriguing. And so what that ended up doing was, it ended up putting me on this path where, again, I lived in both worlds, so I could communicate and interact with the computational people and also with the experimental people as well.
Right. So it sounds like you were able to do things hands-on, the notion of experimentation, you're able to try things, see things, respond to your curiosity, and it sounds like that was, kind of the things that really intrigued you. Are there things that you took from those early years that made you effective, helped become a leader, that you now try to create for your position as a senior executive at NASA?
Well, actually, yes. One thing that was really interesting, I think, in my early part of my career, it seems like every year we had some kind of reorganization or mini reorganization. So I started off doing compressor aerodynamics. After doing that for maybe about 2 years, the project that I was on, it was canceled and terminated. About that time, there were 2 major things that, again, Lewis Research Center at that time was starting to embark on: Space Station Freedom, and then we were starting on the aeronautics side, starting to work hypersonics. And I remember I got a phone call and said, "Hey, we want you to come and talk to us, see if you're interested in coming over to do work in support of space station." And I was like, okay. So I went over and I if you want to say, did an informal interview, had the discussion, and I really wasn't tremendously interested in that line of work. Hypersonics was more intriguing to me because it was this national effort, where we were going to develop, this reusable Mach 25 vehicle that was going to have a variety of breakthrough technologies in it in order to make it happen. And I found that to be more to my liking, and it also was going to offer me the ability to continue doing the work that I had been doing with a combination of experimental and computational work. So got a chance to do that. Got a chance to build a lot of hardware. Got a chance to do a lot of computational modeling, writing codes, modifying codes, applying the codes. Got a chance to interact with people, across the country who work in the National Aerospace Planning Program, people in the Department of Defense, the Air Force and the Navy, also people within the aerospace industry, the airframe companies, and also the major engine companies. So that really gave me, I think, a broad-based exposure to the aerospace industry that maybe I wouldn't have gotten if I had gone in a different direction. I think Secondly, after the National Aerospace Program was terminated, I was kind of at this decision point. At that point, I had finished my master's degree, and I was thinking about, still at that time, I still wanted to be a lawyer, so I hadn't given up the law degree thing yet. And so I actually went and got applications from 2 different law schools locally in Cleveland. And I went in and I talked to my section head at that time. That's when we still had sections before we got rid of branches. And I mentioned to him, I said, well, I still want to do this law degree thing. And he said, well, I'm not sure. He said, I need to have a lawyer doing aerodynamic research. And I said, okay. He said, so if you're interested, he said, it's going to be something you have to pay for yourself. So when I started looking at the tuition for law school, I said, I'm not sure that I want to create another student loan for myself. And went back and had another discussion with my section head, and he said, have you thought about pursuing a PhD? And I said, well, not really. I said, because I really wanted to be a lawyer. And he said, yeah, but you're doing research, you have a master's degree in mechanical engineering now, why don't you think about it? So after probably about 5 or 6 months, I did make the decision that I wanted to go back and pursue a doctorate. And so around that time, when I wanted to go back and pursue a doctorate, I made the switch again from doing hypersonics now, and I went into doing turbine research. So I was doing some turbine aerodynamics and mostly turbine aerodynamics, but a little bit of turbine heat transfer. And so what that taught me was that I had this basic skill set of heat transfer and fluid dynamics, but I applied it to the whole aeronautical propulsion system. And at that time, I also had been doing some space-based and rocket propulsion work as well, especially in the combustion area. So now, I have this skill set where I've done from the front of the engine to the back of the engine. So I really developed this systems view of propulsion. And I think what that's allowed me to do is to be able to understand how you can design something that may be the greatest component by itself, but if it doesn't integrate well into the rest of the system, it's a very limited design. So that's really when I think I developed this more of a systems approach to doing research and also doing engineering related work. It was from having these variety of experiences working on the different components again throughout a whole propulsion system.
Yeah. Now it sounds like you have always liked big challenges. I mean, legal and then science and engineering. It also sounds like you're comfortable to adapt. You run into, you were thinking about doing the law school thing and then the opportunity for the doctorate. And so it would require then having things from a systems kind of perspective because you're going through the whole spectrum, so to speak. So let's come to where we are today. You're responsible for NASA Glenn's research and engineering, getting involved in key issues related to NASA aeronautics and research. And what are some of the key challenges and what are some of the key accomplishments that you're dealing with today?
Well, I think some of the key challenges that we have is that NASA has gone through this paradigm shift over the years. So we have gone from having a fairly robust, what I would call a more basic or fundamental research portfolio to now to more focused programmatic and a more focused set of projects. In order for us to, I believe, to enable the breakthroughs that we're going to need to do some of the missions that we would like to do, whether or not it's for aeronautics or for space, we need to have a more sustained and focused and more robust investment in fundamental research. There are many things that are flying now on aircraft and also on spacecraft because we made those investments in that technology. And I worry that right now with the amount of funding agency-wide that we have going into fundamental research across the board, that we're not going to have the next sets of technologies that we're going to need in order to make those missions happen. People talk about whether or not if it's a mission to Mars. Well, there's a lot of things that we need to do. We have to make sure that for the astronauts that we have technology that provides significant shielding from radiation for them. We have to be able to find breakthrough technology to increase the transit time from here to Mars. We have to be able to create our own power off of the what exists off the Martian surface, so be able to do in situ resource utilization. On the aeronautics side, we still have the challenge of, now everyone's interested in UAVs. How do you safely integrate, uncrewed aerial vehicles into our air traffic control system and do it safely, where you know where everything is, where you have sense and avoid technology there, where we can be able to keep UAVs, out of the flight path of aircraft, so we don't get these near miss type of things. And even from a national security perspective, where we can create the kind of technology from a command and control where we can be able to keep some kind of UAV or UAS system out of people that may want to do harm to our citizens. So there's a lot of different challenges that we have that we need to go work on, and but there always needs to be some level of investment that we need to have as an agency and as a country that's going to allow that next breakthrough that's going to keep us ahead and allow us to keep our technological edge internationally.
And so one of the things, obviously, that means is going into what is a critical competency, what are the critical technologies, and determining those priorities. And I know that you're coming off of a 6-month agency-wide effort across NASA to lead a team in terms of space environmental testing and looking at NASA capabilities and expertise, where we are today and where we need to go. What did you learn from that about the organization and critical competencies, but also about yourself in terms of leadership?
Well, what I learned about that is I'm still amazed how much I still don't know about the agency. And this was actually a great learning experience for me. Again, I've spent a lot of time working aeronautics. In the last probably 7 or 8 years, done a lot more work in the human space flight, but really haven't done a lot of work in the Science Mission Directorate portfolio. And so this gave me an opportunity to really engage with those centers that primarily their focus is in science. So I spent a lot of time at Goddard, spent a lot of time with at JPL and with people from those organizations. One of the great things about that activity is that we had a great group of people, but all those people had their own sets of experiences, and they may not have necessarily an agency experience. And what I mean by that is if you talk to somebody that primarily worked at either Goddard or JPL, and if you shared with them some of the challenges that people in aeronautics across the agency have been having for the last 20 years, they basically had no knowledge of that. Even if you shared with them some of the challenges that the Human Exploration Operations Mission Directorate is going through right now, they really didn't have a lot of knowledge of that. And it's interesting how when you look at history, especially history of our agency, where you have these periods in time where things change. And so, for example, in aeronautics, aeronautics was $1 billion enterprise within the agency in the in the mid-90s, mid to late 90s. Series of decisions that were made by Congress and OMB, and we went from being $1 billion enterprise to almost half of that within aeronautics. That had an extreme impact on the 4 traditionally Cold R, as we call them, aeronautics research centers. So there was things that we had to do as far as our business models, the way that we do business, the way that we would have discretionary resources to do certain research. We didn't have as much of that budget available to do those types of things, especially discretionary type things. So we were kind of the first wave that went through that within the agency. When the shuttle went away, our human spaceflight centers felt a lot of the pain that the Cold R, traditional Cold R centers felt. And so to a large extent, then we ended up in a situation where we have now the traditional science centers, where they've still been sort of insulated from a lot of the budgetary challenges to some extent that the aeronautics centers, traditional aeronautics centers, and then the traditional human spaceflight centers have seen. And so with that activity, one of the things that I learned is that everybody wasn't in the same place. And so I was given this 6-month tasking by Lisa Rowe to go off and do this study and create a set of recommendations on how we may be able to do a consolidation where it makes sense. And then also, hopefully, as we're going through a consolidation, be able to make a set of recommendations that will allow us to be able to strengthen areas for space environmental testing that we know we're going to need as we move out in the future for the agency. So the largest part of that challenge, in many ways, was bringing, again, this disparate group of people together. Some I knew, most I didn't, and develop a trust level with them and a confidence level that I wasn't coming in with an agenda that was trying to steer the answer to where I wanted it to be steered to, but more so I was trying to hopefully create an environment where people felt comfortable enough to bring their different ideas, their different perspectives to the table, and we could have a robust and informed discussion, and then reach a set of conclusions that was in the best interest of the agency.
And how do you do that? Because there are people who don't know you. The natural tendency in any organization is you're coming here to take my funding, you're coming here to take something. So how do you build that trust and get those good ideas?
Yeah, I heard all of that up during the course of this activity. Well, why do you think we don't know how to do this? It just seems like headquarters doesn't trust us. Blah, blah, It was a lot of things like that early on. And so part of it was that we had a lot of dialogue around just the state of the current agency. Okay, and it was really interesting. Yeah, it was a discussion, and there were a number of people on our group, or within our group, that really didn't know that the amount of funding that we were getting allocated from Congress was not sufficient really to care for all the infrastructure and all the resources and all the commitments that we had. There was people really who legitimately didn't know that. And that was probably one of the biggest hurdles, was getting everyone to really understand and accept that that you may be doing okay at your center, but there are other centers that aren't doing okay.
So okay. A situational awareness.
Right.
So what's going on?
And so this is really about NASA. It's not really about Glenn, or it's not really about JPL or Goddard or Johnson. This is really about NASA, okay? And it's kind of difficult to sit back and say that we're okay as an agency where there's parts of the agency that aren't okay, even though you are okay. So I think once we got through that, that was a major breakthrough. The second thing is I insisted, and I took some criticism for this, and that was okay, but I insisted that we visited every center that had assets on this list that we were given. And so there was a couple of things that did. Firstly, we were able to go and put eyes on the assets. We were able to see things for ourselves. We were able to see the physical condition. We were able to talk to the research and engineering staff at the respective centers about the challenges they have with maintaining their facility, the workflow that they have. We were able to do that. And that was tremendously informative. The second thing that it did is, since all of us were from different centers, it gave us a lot of time to bond, okay? And I do mean a lot of time.
Together.
Time
Okay.
together. I can tell you that we had all kind of adventures traveling with lost luggage and delayed flights, and we spent a lot of time in the airport and, just in transit back and forth going to the various centers. And that helped tremendously in building trust because we got to know each other, I think, in a different way than just doing the work. And that helped a lot. Thirdly, is once we completed all the visits, we had a meeting here at Glenn in July, and I told folks at that time, I said, one of the things I said I want to be able to do is I want to get all the data out on the table. And I said, so one of the things I want you to do, and each center representative, because we had center representatives and we had mission director representatives, I said, each center, I want you to come in, and if you were king or queen for a day, tell me what space environmental testing assets you would want to keep and which ones you would want to get rid of. And almost every center did that. And it was not me telling them. I said, you come in and you tell me what you would get rid of. I said, because there's going to be a point in time where it's going to cease to be a democracy. And I said, and there will be some hard decisions that will have to be made. So while it's still a democracy, tell me what you would do if you had the ability and the resources to go do it. That helped tremendously in getting everybody past. You're trying to take my resources and my test facilities away from me. You're trying to disadvantage my center, and benefit another center. Because now it's their input. They're owning it. It's not me owning it, it's they are owning it. And so that really helped get us on this path where the next couple of months was going to be really hard as far as some of the discussions that we needed to have.
Was there though a consolidation of agreement around certain things that you got to keep or certain things?
Yes.
Okay.
Yeah. So
Which
there
would
was
make it easier. Then.
Right. So there was. So we were able to converge on some things where it was pretty clear that we had to keep because it was a national capability, not only for NASA but for the aerospace industry.
Could you give an example?
So for examples of that is the XRCF facility down at Marshall Space Flight Center. Okay, it's a one-of-a-kind thermal vacuum chamber for optical telescopes. One of the things that I was also asked to do during this study was also interact with industry, and I interacted with industry, and industry said there's a lot of things that you may want to get rid of, but we have got to have that. And there was a consensus even from our team that that's such a unique capability within the agency, you have to have it. The space power facility at Plumbrook Station, here at Glenn in Sandusky, Ohio, same thing. The world's largest space simulation chamber. You can do full-scale deployments of payload shrouds and other kind of space hardware. Got to have that capability. Where else does it exist? in the world. It doesn't. So that was an example. And so we had this July meeting, and then we had a August meeting at Goddard. And so we were getting to the point now where by September 30th, I was supposed to be presenting to MSC the results of this team. So we had this meeting at Goddard, and we started discussing, and this is a real hard part of the discussions. Okay, what is the complete list of things that we believe that we got to have? What are the things that are unique to the agency? What are the things that are unique in the nation? And then we had some categories where there was a lot of overlap. And so we started that exercise. And so we went through and we came out with a list of these are gotta have, so we can just take those off the table, don't even discuss those anymore. And then we said, okay, which things are unique within the agency? And then unique nationally. We went through that discussion, and then we pulled those off the table. And then we had these several categories, well, actually it was about 5 or 6 categories, where it wasn't clear to us, because we didn't necessarily have all the subject matter expertise on our team, where all these assets should fall. Okay, is that just a capability that needs to reside at one center or at multiple centers? And so we went through that discussion, and that's where we ended up getting a lot more conflict. Okay? And so actually what I did in preparation for that meeting, I had a set of questions. And I said, if the agency were to make a decision that, for example, electric propulsion should be done at 1 or 2 centers, what would our asset list look like? How many things would fall off the list? That was very contentious. It was very contentious, and we had some facilitators there, and they helped get us through it. And because I'm not sure we could have gotten through that, but we got through that discussion, and so now we had these, what I considered to be these sets of facilities that had questions attached to them. And so part of what I wanted to be able to do was to go back and engage with Lisa Rowe and say, Lisa, this is kind of where we're at. We have these list of facilities that have questions attached to them. What should we do with these? A lot of that's predicated on how the agency wants to define roles within the agency at the respective centers. And we don't believe that's our job to do. I said, but these are legitimate questions, and depending on how the decisions are made is going to impact how many of these assets that you have that you may be able to consolidate, and you may be able to reduce the overlap. And so to me, so this was August. So we got to, we were going to have another face-to-face meeting at Johnson, and this is a really interesting meeting that was going to happen. So this was like kind of like crunch time is on. It was first week in September. We had less than 30 days to pull everything together. And so that weekend before I was supposed to go down to Johnson, I had a little accident at home. And so I came into work that Monday, and I wasn't feeling good, and I was supposed to get in a flight that afternoon, and I actually ended up checking myself into the emergency room. And so the meeting was supposed to be Tuesday and Wednesday at JSC, where we're going to make all these critical decisions. And I ended up not going, because I ended up spending like the whole day in the emergency room. And so I sent an email out that night when I got home from the hospital, and I told the team, I said, I'm going to connect in via telecom. And the interesting part of what happened is I started getting all these emails back from the team members. And it was, no, don't connect. You've been in the hospital all day. We got this. Let us handle it. And I'm saying, okay, well, I had less than 30 days to get this thing. And, I start typing. I said, no, I'm going to connect in. And then I got another email, Ricky, just rest. We got this. I said, okay. So for the next 2 days, I was at home, and I was recuperating. And at the end of each day, they would send me emails, this is what we accomplished. And they got everything done that I wanted to do. Okay? And so what that told me is that at that point, and I felt that we were there, but this was a validation that everything we had been doing, trying to build the team and build the trust and the confidence and the belief in each other, we were there. Because the true test of how you build a team is not the leader, but it's about the team.
So you'd built this, or the team had created a trust level with each other, and then you also had that trust for them because you had to make that decision of pulling out.
Right,
Stepping
and when I
back.
pulled away, and then that again was validation for me that we were a team. And that's part of the challenge of leadership that I think that sometimes that people get lost in. When you're leading, it's not important that the focus be on you. It's really important that the focus is on us. And for the team to pull through at that point, because I was the person whose name was on the presenters list to come present this package. So I had to have enough trust and confidence in them that they were going to make the right sets of recommendations, right set of decisions, okay, per that final face-to-face meeting, and that we were going to go in and I was going to be prepared and I was going to present a product that our team collectively came up with that everybody stood behind. Because I did not want that to be, well, this was Ricky's recommendations. Because if it was Ricky's recommendations, then I felt that that would have lacked credibility. But it was our collective recommendations.
So one of the things I've heard before that would apply to you is to be a leader. It's not important. The most important thing isn't to be interesting to others who are listening to what you have to say, but it's to be interested in what your team has to say and to pull that together, and that led you to a good path. There are also a number of things. You started off by creating a situational awareness that, hey, this is the situation we're in, things have changed, that's going on. You created a team, you came together physically. People were telling you, I guess, not to necessarily travel, but coming together, laughing, getting stuck in airports was important. The ability to listen to people in terms of what their data is and what's being presented, and then to be able to step back a little to let others seem to be some of the key things that you had there.
Right.
So.
And I think that those are all key aspects of what a good leader does.
Yeah. So we have, which is an amazing agency-wide story there. You have some questions from our audience here, and let me get into that in the time that we have. And so one of the questions is, what are some of the key challenges you faced as you were building an organization responsible for both research and engineering development? So a few years back, you were appointed as Director for Research and Engineering. What are some of the key challenges in building an organization?
Well, I think the key challenges in building the organization was firstly, for so long it was seen as our research and technology directorate and our engineering directorate that the things that they were responsible for doing were somehow disconnected and they weren't necessarily joined. So that was one of the key challenges.
So seeing at a systems level.
To seeing
again,
that these things are connected and that we actually can embrace the power of merging our organizations and being able to bring to bear research where applicable to help to solve some of the engineering challenges that we may have. And we've seen some examples of that since we've done the reorganization, which has been really good. Secondly, one of the challenges I think that we've had is that from a career path perspective for our employees, there was a research path and there was an engineering path. And going each one of those paths, you had to do certain things as far as whether if you're on the research side, publishing, patents, your engagement with technical societies, things like that. On the engineering side, it was more, getting products done, okay, getting missions out, those type things, and showing that again, there's value in both of those. Okay, it's not a research versus engineering, it's both. And how do you embrace both of those? And that's part of our continuing messaging and our continuing challenge. I think we've done that successfully in some areas, but I wanted us to see it, us to do it more. I wanted it to be something that's second nature to us, that we just embed in everything that we do.
So it sounds similar to the agency-wide activity. It's the seeing things as an integrated, function, the synergy, the working together, the collaboration, and moving forward in that direction.
Absolutely.
Another question that came, this comes from the standpoint of people early in their career who are interested in managing. What have you learned about leading people that you would impress upon others who are interested in management and leadership?
Well, one of my mentors, and I've been fortunate, I've had a number of mentors throughout my career. And even when I was in college, even when I didn't realize I was being mentored, I was being mentored. But one of my mentors that even today, it always sticks in the back of my mind. One of the things he said to me is that, when you're in a position of leadership, he said, it's not important that you're the smartest person in the room. He said, it's not important that you have all the answers. He said, what's important is knowing how to get everybody else to get to where you're at. And I thought about that when I was leading the space environmental team. That's one of the reasons why I went through a couple of months of the situational awareness. I was trying to get everybody else to be where I was at. If I can get them to be where I was at, it was going to make the task that we had in front of us easier, because now everybody understands that this is just not something I'm saying, that this is a reality, and that they would approach the answers that we were trying to come up for the agency in a way that they embraced. And so that was one of the key things. I still remember when I was first selected as a branch chief, and my division chief to me said at the time, he said, I'm going to introduce you, he said, tomorrow. He said, what are you going to say? And I went home that night and I was talking to my wife. I said, I have no idea what I'm going to say. And then my wife was looking at me and she said, well, just speak from your heart, just speak how you feel. And I said, well, okay. So when I went in that next morning and I was introduced, and actually on my, I got up that morning and I was getting dressed and it came to me what I should say. And what I said, and I still believe it to this day, is that my success is tied to your success. If you're successful, then by default I am. So the things that we're going to be doing is things that I believe is going to help you be successful, and then everything else will take care of itself. And so to me, that's kind of leadership 101 at its best, is that. And so I've always tried to lead from that perspective. And so at the end of the day, regardless of what organization that I've led, and I've been fortunate to lead a number of different organizations, I can look back and I can answer the simple question, which is my simple metric for myself, because everybody has metrics. Did I lead the place better than what I found it? And yeah, I can answer that question pretty confidently.
And there's a consistency in terms of your focus on team collaboration and facilitating conversations.
Well, it has to be. And I think that we were having this conversation here, I don't know, maybe before Christmas. But, most of us are technically trained. We don't take courses when we're going through our engineering curriculums and how to be effective communicators. We don't take courses in conflict resolution. We don't necessarily take courses in how to build high-performing teams. That's not part of your engineering curriculum. Right? When you look at engineering curriculums now, they try to infuse some of that into the curriculums now. And that's, part of the accreditation criteria, now, because that was something that's been lacking. But for folks my generation or right after my generation, that wasn't embedded in our curriculum. So a lot of that I've had to learn as I've gone through it. And so, how do you become, a lot more collaborative, and you do it in a way that you allow others to be heard, but then you're not sacrificing what you believe. And that's an art, okay? There's not necessarily, a how-to book for it that you can go Google. And some of it is trial and error. And so I think over the years that, I've been able to do that. And I've also been able, one of the things that I kind of pride myself on is I'm an observer. I see a lot of things and I pay attention to a lot of things. And I think that over the years I've seen people who I thought were really good leaders and really good managers. I've sort of taken bits and pieces of all these different styles I've seen over the years, and I've sort of melded them into my own.
So learning by observing.
So yeah, I see it. I'll say, hey, that was really nice what you did in that meeting. And if you are really observing and really trying to absorb what you see, you may actually be able to see how that impacted folks in the room. Okay, because you had one behavior, maybe it was a positive behavior and it had a positive impact, or you had a negative behavior and it was a negative impact. Okay, one of the things I try to do quite a bit, a lot of folks may not necessarily notice about me, but I do ask for feedback from people. And I ask it in a way because I don't want to just hear things that people think that I want to hear. I want to really hear the things that I need to hear. Because organizationally, if you don't, then that's how you create these blind spots. And I think the history of our agency is that we've done that, where we've had situations where people were telling people what they wanted to hear, not what they needed to hear, and we had some tragic consequences as a result of that.
So I think we're coming down to the final few minutes, and I've got like another 15 questions. So let me go to one I did want to ask you.
Okay.
Because one of the themes you've had is working across the organization, heading up, obviously, research and engineering, doing agency-wide. And you alluded to the need for understanding the critical knowledge that the agency has, being able to make sure we have expertise not only today but in the future.
Yeah.
How do you go about as a leader creating an environment where there is an active transfer of knowledge, so that if I have a great capability and I'm interested in doing what I'm doing, and when I leave, but you have to be concerned with, identifying what's critical for the future, but also then being able to maintain that and share it. Are there certain things that you try to do in your role to get people to share their expertise, to share their knowledge, knowing that there's always a competition between, I got to get this job done? How do you go about, promoting a transfer of knowledge and expertise?
Yeah, that's a very complicated thing to do in our current environment. And what makes it really complicated is that, I go back to the example when I told you that one of the senior engineers came in and grabbed me and said, hey, come on, we're going to go over to this compressor experimental facility and we're going to show you how to run experiments. Well, that was at a point in time when there was still fairly significant hiring. You had the opportunity to be able to now have some senior more senior folks in your organization, mentor and work with and transfer knowledge to more junior folks. And we haven't had an opportunity in many respects to be able to do a significant amount of hiring. So we have certain organizations where we have these pockets where we have these, fairly significant bimodal age distributions. And in some cases, we haven't had hardly any hiring. I was looking at some demographics within our organization, and you can see that even there was a period in time where we had really critical needs, and we were hiring experienced people. We weren't hiring any, essentially what I consider early career fresh out. And so what's that's done over time is led to, I think, this break in the system where we've been able to have some more junior folks paired up with more senior folks and be able to do that knowledge transfer.
So mentoring and reverse mentoring and
I mean, exactly.
shadowing.
So like for example, I was telling you that one of the things that I did a lot of work in was like fluid mechanics, fluid dynamicists, aerodynamicists. I learned how to do hot wire anemometry from a more senior individual. Okay, I read about hot wire anemometry in a textbook. He actually showed me how to do it. Okay, and it was actually a really good partnership because I knew how to do a lot of computer programming, computer coding. So he relied on me for that to help him sort of post-process and automate the analysis of his data that he was getting from hot wire anemometry. So I was showing him how to do that, and then he was showing me, the art of, putting these fine instruments into an airflow and looking at a voltage meter or an oscilloscope and making sure you have a good signal and blah, 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 and what does that mean and how to convert that information. And so now the thing that I get more concerned about is that when you look across the agency, everybody's project is important. And so sometimes we don't take the time to be able to grow and develop the skill sets within our junior people when we are fortunate enough to be able to get them hired into the organization, because everything is a fire drill. We got to go and we got to get this done. We got to get this done now. We got to get this done now. And we have to create those opportunities. We also have to create those opportunities to let people know, hey, it's okay to put some more junior people on some higher priority work. They may make some mistakes, but that's how they learn. That's how I learned.
Right.
I mean, I broke enough hot wires in my time, okay, by learning that, hey, these things are tremendously delicate and sensitive instruments, okay? You have to treat it as such. Well, if I hadn't been physically interacting with that instrumentation and doing it, I wouldn't know. But now I know. And I know that's how, in many cases, that's the best way for people to learn is by going through that process. So one of the things that I really want to be able to do is try to get something that's more systematic and that's more engaged. Again, where it's not that people feel that they have to go out their way to make it happen, but it's something that happens more natural.
So the transfer of knowledge comes at an expense by making sure people have the time to work, to learn from each other, to share. So it's heavy people-intensive exchange.
It has to be. It has to be, in cases where it's applicable, the hands-on engagement. Right. Okay, that has to be an integral part of what we do as well.
Okay, so I think we are probably at time. Because of your calendar. I know I didn't get to some of the questions.
No, but I still have a little bit of time.
Okay, so if we can...
I'm just delaying, I'm delaying Derek's meeting.
Well, I'll take advantage. One of the questions that came is what technologies are happening today that amazes you in terms of, I guess, related. You're talking about in the early career, some of the modeling tools were outdated methods. What is it that you see today in terms of technology that really amazes you? that excites you in general?
Well, one of the things that's really amazing me as far as technology is I think that we have a unique opportunity to do something fairly significant in materials development. We have shape memory alloys now where we can deform the shape of a material and be able to use that in different kind of applications, which is really, really good for things that we do, especially that NASA's interested in. But I think that we have a really unique opportunity agency-wide to go and develop a whole class of materials that's going to change the whole power density equation. People were talking about hybrid electric aircraft. People were talking about Mars missions and having a Martian habitat. We need to look at significant increases in power densities. And I'm talking about, factors of, orders of magnitude changes, okay, in order to make that happen. People talk about hybrid electric right now. Can we fly a hybrid electric aircraft? Yeah, you can fly a hybrid electric aircraft, but it's not going to be no one on it except the pilot by themselves. Okay, just because with current state-of-the-art technology and energy storage, whether it's a fuel cell or some kind of battery system, the volume of it is just so massive. So if we can do something that changes the power density the same way that we're doing with Moore's law and computer circuitry, right? I mean, every time I look and there's another commercial for a new smartphone has the latest chip in there. That chip is already obsolete because somebody's already working on the next evolution of what it's going to be, a faster chip. If we can do the same thing in power, if we revolutionize the way that we do look at power from the work that we do, again, the aerospace industry, but it would also have tremendous benefit to what's happening as far as terrestrial power and the power that we produce and the way we manage power here on Earth. So, to me, that's an area that's ripe for technology infusion and infusion of resources. And it's also multidisciplinary because if you move it along the spectrum where now you have this order of magnitude increase in power density, you're going to need smart sensors, you're going to need control systems, you're going to need all of that to go along with it. So it's going to be something that's going to be tremendously multidisciplinary. And it's just not going to be, I just develop a material for this. No, it's going to be a material that you develop for these types of applications.
And related to that is a question saying, what do you anticipate Glen's role will be in space environment durability?
I really can't answer that question. There's a group of folks, the technical fellows that are still working that. I know there's a new technical fellow, Dr. Joseph Minow, that's looking at that. And so that really wasn't necessarily the goal of my team, even though it's connected, okay? We were looking at testing assets, but we weren't looking at the other piece of the equation, which is what skills exist across the agency, all the things that we believe that we need to have from as far as tools, including computational tools and other tools that go along with that. So there's other pieces of that puzzle that need to be brought to the table in order to answer that question.
But what you said before, it sounds like you see an exciting future.
Yeah, but I would tell you at the end of the day, if we're going to keep doing space missions, robotic and human, right, we're going to have to do space environmental testing. Now, people may debate, and it's a fair debate to have, what amount of testing do we need to do, right? Because programming projects, we have that debate all the time. Okay, how much do I want to set aside for being able to do certain type of testing to buy down risk, right? Because at the end of the day, that's what I believe the question revolves around. How much risk do I want to accept for my particular mission? Okay, Some program project managers may be more tolerant to risk, some may be less averse. And so I think at the end of the day, we're going to continue to have this, I think, really engaged discussion about how much risk do I want to have. Because, again, just from the work that I've done experimentally, you should be testing the way you fly it.
Right.
And if you put the investment in here before we send it out there, chances are we're going to have a better outcome.
Right. Test as you fly, fly as you test.
Exactly, and that's what I firmly believe.
Right. And so a final question is NASA leadership activities around consolidation seem to only focus on the core competencies, and the support activities such as instrumentation and measurement are forgotten. So the premise here is that the focus of consolidation is on core competencies and we don't think about support activities. How do you think this could be addressed?
Actually, they're starting some activities around instrumentation and some of the other adjacent supporting technologies. When the Office of Chief Engineer first stood up the technical capability teams, they stood them up in areas that they thought were the right areas. And so now what they're seeing is that there are gaps. So that's how the space environments, testing, technical capability team was put in place. They're looking at one for instrumentation. And there's a couple other ones, one just put in place for systems engineering. And there's several other ones that they're looking at because they see that there's gaps, that we didn't cover the whole waterfront of technical capability that exists within the agency. I can tell you one that I believe that we're probably at some point going to have to look at. There's not a technical capability team for communications. Right? Some of the communications technology that's developed, some of us under avionics, as a technical capability team for avionics, and some of it may exist under instrumentation. But communications is a critical piece of what NASA needs to do if we're talking about, again, having a broader set of either human or robotic deep space missions. And also, I would say, even if we're going to solve this conundrum of opening up the National Aerospace System, with human piloted aircraft and unmanned piloted, uncrewed piloted aircraft, you're going to have a robust architecture, communications architecture, to keep everything safe, to know where everything is, to be able to sense and avoid and control and command. And so, but we don't have a capability leadership team that's looking at that, right? And there's multiple centers that do communications technology. Glenn does it, Goddard does it, JPL does it, right? And some other centers that have lesser roles in it. So should we be looking at that? Yeah, we should be looking at that because there are technologies that we need to, again, if we want to do further exploration of space and go out further than what we've been. The current state of communications technology is not going to be sufficient. So I do believe that there's other areas that we need to go address, and I think some of those will get addressed as time goes on. This is the first time the agency's embarked on an effort like this, so the first time out they're not going to get it right, but at least they're listening and they're evolving the process as we move along.
So it's a journey.
It's a journey.
And you've had quite a journey in terms of your career. I guess, are you happy that you didn't go into law, as it turned out?
Let me see. Yeah. I may be happy. My bank account may not be as happy as it could be. But, when I look back on my career, I have no regrets. I think I made the right set of decisions. It's been great. I think if you go back and you look at the high school yearbook and it says, I think for me it says, what are your career aspirations? I said lawyer or engineer, right? So, you know, I'm batting 500.
There you
so,
go, which is pretty good.
So I did one of them. So that's, you know, so that's good. And again, I think that some of the things that I've been able to experience, that we've been able to accomplish within this center, within the agency, has been fantastic. And I'm not so sure that I would ever be able to tell people in its entirety about this journey.
Well, I appreciate you taking the time.
Well, thank you.
It's been great to talk to you and to share some of your insights. I feel like we kind of touched on just a small percent. The time went very fast, but hopefully maybe we'll do it again.
Okay,
And
that's an
wanna
open
thank,
invitation, right?
Absolutely.
Okay, I'll take you up on it.
And I want to thank the folks here at NASA Glenn Research Center. So thank you, and hopefully you'll come back for one of our next Masters with Masters. Thank you.
Thank you. Thanks,
Thank you
Ed.
very much.